Good afternoon, class. Here's exam 2 review covering sections 3.2 to 3.5. 3.2, the derivative as a function. 3.3, basic differentiation formulas. 3.4, the product and quotient rules. The last section is the chain rule. There's a pledge before starting any exam. I pledge on my honor that I will neither give nor receive unauthorized assistance during the exam, any exam. Unauthorized or quizzes for that matter. Unauthorized actions include, but are not limited to, the use of notes, text, graphing calculators, search engines, PowerPoints, or any other resource. Any other resource is not explicitly allowed, including AI. All right, differentiation formulas, starting with a line, a blue line giving 2 points. Rise over run represents the slope of a line, an average rate of change of y with respect to x, and there are different ways of writing them. For example, f of x minus f of a over x minus a. Now, if we take the limit, for example, f prime of a, limit of f of x minus f of a over x minus a as x approaches a, or limit of f of a plus h minus f of a over h as h approaches 0, this f prime of a represents the slope of a tangent line at x equals a. An equation of a tangent line would be y minus f of a equals f prime of a x minus a times x minus a, or just use the point slope. Definition of a differentiation operation. dy dx is limit of delta y over delta x as delta x approaches 0, or f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. And then we have some formulas. For example, the power rule, the derivative of x to the power of n is n h to the power of n minus 1. The derivative of kx is k. The derivative of e to the power of x is itself. And then we have trigonometric functions. The derivative of sine is cosine. Cosine is negative sine. The derivative of tan is secant squared. Cotangent is negative cosecant squared. The derivative of secant is secant x tan x. And the derivative of cosecant is minus cosecant x cotangent x. We have the product rule, the quotient rule, shorthand notation, composite function, resulting in the chain rule and the extended power rule. Definition of a natural log, y equals ln x, means e to the power of y equals x. And the derivative of exponential functions is also always itself, in this case times k by the chain rule, in this case times g prime by the chain rule. And if the base is anything other than e, then the function itself times ln b, this is logarithmic property, times f prime of x by the chain. So for example, let's get started with these examples. F of x is 2 over 9, x to the power of 5 over x to the power of 9. And I'm going to remind you that for this piece, we are going to use this quotient rule of exponentials. So it becomes 2 over 9, x to the power of 5 minus 9, which is negative. To differentiate this, of course, now we use the power rule, 2 over 9 times negative 4, x to the power of minus 4 minus 1, or minus 5. In other words, this one is now 2 times negative 4, negative 8 over 9, x to the power of minus 5. So we take it down using negative exponential rules. We take this down, we make it x to the power of positive. For part B, we notice if we make up two fractions, this is 10, this is minus 7x, and the f prime becomes simply minus 7. There's really not much to it. Y equals 5 to the power of sine x. We really can use this one, but I want to quickly show you how we arrived at it. So when the base is not e, let's say, for example, b to the power of x, reminding everyone according to logarithmic properties, ln of e to the power of x, as well as e to the power of ln x, both of them are x, because they're referring to the fact that the exponential and logarithmic functions are inverse of each other. Therefore, b can be replaced according to this to e to the power of ln x becomes e to the power of ln b. And so b to the power of x is e to the power of ln b to the power of ln x. And if you look at this power rule, a to the power of m to the power of n means a to the power of m times n. So that means e to the power of ln b times x. And ln b, just compare this to this one. It's identical to this concept because ln b is a number, just like k. So the answer is itself times ln b, just like e to the power of kx. And this one, we put it back in the form of b to the power of x. Now, if by any chance we have b to the power of f of x, we also tag along f prime of x. Having said that, the derivative is itself. The base is not e times ln 5. This is by logarithmic properties that were discussed here. And then sine, it's a function of x. Its derivative by the chain rule is cosine x. And we rewrite it as cosine x ln 5 times 5 to the power of sine x. This would be the final answer. All right, so now we're dealing with trigonometric functions, more specifically sine and cosine, reminding you the derivative of sine is cosine, the derivative of cosine is negative sine x. Now, what if instead of x, we have a function of that? For example, the derivative of cosine u would be negative sine u du dx. The derivative of cosine of g of x would be minus sine of g of x g prime of x. You can go with that, or the methodology that I have discussed before. So when I come across any trigonometric function, I'm going to read as cosine, for example, here, and I'm going to pause. The derivative of cosine is negative sine. Now, any trigonometric function is meaningless without an argument. So it must have the same argument. Now the chain rule applies. The derivative of 2x is 2, and you rewrite it. Minus 2 sine of 2x. That's how you rewrite that, everybody. The second one, we're going to rewrite it as cosine of x to the second power, so it becomes clear that we're going to use the extended power rule. So we're going to write y prime is 2. Then cosine x to the power of 1 is simply cosine x. And now we need the derivative of that. The derivative of cosine is negative sine x. And we write it as y prime equals negative 2 sine x cosine x. So you may recognize this as minus sine of 2x. This is the sine of double angle. So what about this one? Again, we're going to look at this one and say cosine. The derivative is negative sine. But negative sine of what? Same argument, namely x squared by the chain rule. We need the derivative of that argument, 2x, and we rewrite it as minus 2x sine of x squared. It's important to write it properly, everybody. Y equals sine squared 8x. Let's write it as sine of 8x to the power of 2. By the way, this comes from mixed derivative practice. You can find it on the module 12 Canvas. I'm hoping that everybody is working on them as practice, so it helps them with the exam. So sine 8x to the power of 2, we are going to use the extended power rule. So we're going to write 2 and then sine of whatever, in this case 8x to the power of 1, or simply don't write the exponent. Now we are going to multiply it by the derivative of sine. As you know, the derivative of sine is simply cosine. So cosine of 8x. But now 8x, by the chain rule, again, its derivative is 8. And we rewrite it as 16 sine of 8x cosine of 8x. Just in case 2 sine 8x cosine 8x is sine of 16x, so this becomes 8. If anybody is interested, this is 8 sine of 16x. Okay. In other words, this is 8 times 2, just in case. All right, we're going to differentiate this, and we notice is the product of 3x and 3 to the power of x. So we are going to call it f times g, and we're going to use the product rule on that. Therefore, we need f prime g plus g prime f. F prime is simply 3 times g is 3 to the power of x plus g prime. Any exponential first you write itself. Then the base is not e, you need ln 3. This is done times f prime 3x. So we are looking at f prime g. So this is f prime g plus g prime f. All right, this would be, and I put asterisk next to it, this would be the only calculus step. However, we are not done, and that's important to know. For your exam, you must finish the job. Even if a question like this is acceptable as the final answer for MOM, your digital platform, My Open Math, is not good enough. Notice this one has exponent 1. This one has exponent x. Therefore, we can use the product rule of exponentials and say this is 3 to the power of 1 plus x, or x plus 1, makes no difference. And this one also is 3 to the power of x. This one is also 3 to the power of 1. So we can mix the two as 3 to the power of x plus 1. We are left with ln 3 as well as x. So now 3 to the power of x plus 1 is in common. If I take this out, then this gives me 1, and this gives me whatever is left, ln 3 times x, which we write it as x ln 3. Just in case this is question 14 of mixed derivative test. So we are multiplying x to the power of 4 by e to the power of 2x. We put a raised dot and we call it fg, and we are going to use the product rule, f prime g plus g prime f. So f prime is 4x cubed times g e to the power of 2x plus g prime. What is g prime? Any exponential, first the answer is itself. Then the base is fine, it's e. The exponent, by the chain rule, we need this derivative, which is 2. And then times f, which is x to the power of 4. Again, I put the asterisk next to it. Or in fact, I'm going to box it, meaning this is the end of calculus. However, as I mentioned before, this is not a finished job. You have to finish it. So to do so, we find a common factor. I hope you realize between 4 and 2, 2 is in common. X cubed and x to the power of 4, x cubed is in common, and these two just e to the power of 2x. So the common factor is 2x cubed e to the power of 2x. If I divide this one by this one, it just gives me 2. If I divide this one by this one, it just gives me x. Therefore, 2x cubed e to the power of 2x times the parentheses 2 plus x is the final answer. We want to differentiate p of x is 9 times x minus 1 to the power of 4. And again, it's coming from the mixed derivative practice. So having said that, remember when we have a number in front, we have two choices. We can say it's part of x and it's 9x times that, or just separated with this brackets, meaning this will carry over. And normally when this number is extremely large or it's a fraction or a decimal, that's a good practice. But either way, you can always do that. Therefore, 9 remains, and you're dealing with the product of x and x minus 1 to the power of 4. We're going to write it f times g, and we are going to use the product rule again. Bear in mind. And the way I'm going to approach questions like that, if I come across that, I'm going to write that formula from the memory, and I'm going to apply that instead of writing ddx of this, ddx of that. So 9 remains, and x, you differentiate f prime gives you 1. So that's f prime times gx minus 1 to the power of 4 plus g prime. Now I want to differentiate this obviously using the extended power rule. 4 x minus 1 cubed, 4 minus 1 cubed. The derivative of the inside happened to be 1, but write it in case it's something else. So get to the habit of writing it. And now times f, which is x. In other words, we have f prime g plus g prime f. So what's in common? X minus 1. What exponent? 4 or 3? Obviously 3. So 9 times x minus 1 cubed. If you divide this expression by this, it just gives you x minus 1. And if you divide this one, it gives you 4x. Brackets will simplify because we can combine x and 4x into 5x. The final answer, p prime of x equals 9 times x minus 1 cubed, and the bracket changes to 5x minus 1. This is the final answer, everybody. Y is 4x over 2x minus 9 quantity cubed. We want to differentiate that, and we're going to start with the extended power. So first we start with number 3. Then the whole thing to the power of 2, that means squared. And now the derivative of the inside, that's the extended power rule. The inside, we're going to write it as f over g, and it requires the quotient rule. So it's a combination of a chain rule and a quotient rule. So to differentiate this f prime g minus g prime f over g squared, f prime is 4 times g, just 2x minus 9, minus g prime, the derivative of 2x minus 9 is simply 2, times f, which is 4x, and then put the bottom, 2x minus 9, g, and square it. Again, this is the end of calculus, but it's not finished. And I can't emphasize this enough. This may be acceptable in some instances by a digital platform you're working with as the final answer. It's not the case as far as the exam is concerned. Make sure you finish it. So we're going to distribute. We get 8x minus 36 minus 8x. 8x minus 8x cancel each other. So what do we have? We go with a fraction bar, and what's at top? 3. What else? 4x quantity squared. This one you should recognize it at 4x to the second power over 2x minus 9 to the second power. So at top we have 3. 4x to the power of 2, and negative 36. What do we have at the bottom? 2x minus 9 to the power of 2, 2x minus 9 to the power of 2. That means 2x minus 9 to the power of 2 plus 2, which is 4. This is 16x squared. The product of 3 and 16x squared and minus 36 is at top. The bottom is 2x minus 9 to the power of 4. So the top has a negative sign, and 1728x squared, you keep the negative sign either in front of a fraction bar or at top, either way is fine. But you keep the negative sign, that's important. H of x is cosine 5t over 5t. We want to differentiate that. The first thing is to simplify. There's nothing to simplify. We're going to write it as f over g. And we are going to use the quotient rule on that. So having said that, we need f prime g minus g prime f over g squared. So f prime. You're dealing with cosine. The derivative is negative sign. And of course, you need the same argument, whatever this one is. By the chain rule times the derivative of the argument, which is 5. And again, you can think of this. The derivative of cosine is negative sign. The derivative of cosine of u is minus sine u du dx. The derivative of cosine of g of x is minus sine g of x g prime of x. So this is f prime times g times 5t. Minus g prime, the derivative of the bottom is 5 times f cosine of 5t. And the bottom is squared, 5t squared, quantity squared is 25t squared. And this is it. You're done with calculus. So f prime g minus g prime f. And now you are going to take a common factor. The common factor is 5 as well as a negative sign. So if I take negative 5 out, this gives me 5t sine of 5t, and this just gives me cosine of 5t. I can see the common factor of 5 from the top and the bottom. This gives me negative 1. This gives me just 5. So the numerator, in essence, has a negative sign in front of a parentheses. So I'm going to keep the negative outside the fraction bar. It makes no difference. But please understand, if you want to put it at top, this becomes negative. This becomes negative also. Minus 5t sine 5t plus cosine 5t over 5t squared, because this 25 reduces to 5. What about y equals 2x squared plus 9x plus 9 over x plus 3? If you have a rational expression, the very first question is, can I factor and simplify? Number one, even if you can factor, but it doesn't have a factor of x plus 3, it doesn't simplify. So you're hoping it has a factor of x plus 3. So in fact, if you think of that and try it, if it doesn't work, it doesn't work. 2x squared means you have to have 2x. And 9 means you have to have 3. And it happened to work. How do you know it works? You have to check the middle term. How do you check it? You want to see if you get 9x. So take a look at this one. The product of these two is 3x. These two, 6x. If you add them up, you do get 9x. It works. Okay? And so drop the common factor of x plus 3. And this one, the derivative is simply 2. So it becomes extremely simple. Always you use your algebraic techniques to speed up the process. The growth in world population in millions is estimated by the formula P of t is 8200 e to the power of 0.011 t, where t is the number of years since 2025. Find the instantaneous rate of change for the year 2050, include units. This one class, you should always include units if you're dealing with an application. So simply put, instantaneous rate of change. First, you have to differentiate. So we want p prime of t So we start with 8200 because that's there. You just keep it. And you're going to differentiate this, which is itself, because exponential, and then times 0.011, just e to the power of kx is e to the power of kx times k. The product of these two numbers, we put it in front and we say p prime of t is 90.2 e to the power of 0.011 t. Now, t is the number of years since 2025. So the difference between the two is the value of t, and the difference is 25. Replace the t with 25. So we want p prime of 25, which means 90.2 e to the power of 0.011 times 25. You put it into a calculator, gives you a number. As far as the number of decimals is concerned, always put as many decimals as possible, unless they ask you otherwise. You definitely want to follow what they ask you, and you put the appropriate number of decimals. In other words, just make sure you read the question. Now, what about the units? And we want to discuss the units. This one, everybody, means dp dt, the change in population over change in time. Therefore, the change in population, millions of people over change in time in years. So we have 118.7511 million people per year, and we want to know what it means. In 2050, the world population will be increasing at a rate of 118,751,100 people per year, if this trend continues, of course. Okay. So that's important to understand, everybody. The length of growing Tasmanian devil is estimated by the function L of W is 2.265, W to the power of 2.543, where W is in kilograms and L is in millimeters. Its weight can be estimated by W of t equals 0.125 plus 0.18 t, where t is its age in weeks. How fast is the length of a 30-week-old Tasmanian devil changing? So we want the LDT, the change in length with respect to time, the LDT. So going with the Leibniz's notation, dy dt is dy du dt. U is the intermediate variable. So from L to t, the intermediate variable is w. Therefore, dl dw times dw dt. So we are going to differentiate each piece. This one with respect to w becomes 2.265 times 2.543, w to the power of the same minus 1. That means 2.543 minus 1, or 1.543. And dw dt is simply 0.8. Now we put the numbers together, this one, and this one, and we get 1.0367811, w to the power of 1.543. Please understand, you want to carry a lot of decimals in between. At the end, you may do the rounding. So having said that, how fast is the length of a 30-week-old Tasmanian devil is changing? If we happen to have the weight, we can do that. We have two choices. We can replace the weight with the function 0.125 plus 0.118 t and replace the t with 30, or just let's plug it in here and find the weight. And the weight is 0.125 plus 0.18 times 30, resulting in 5.525 kilograms. Now we can replace this and putting it into a calculator with a bunch of decimals results in 14.4912, almost 14.5. Units of length, millimeters, over units of time, weeks, millimeters per week. So the units should always work, and they do. Because the composite function, if you want L of W to get to L of T is easy, you can replace the W and get L of T. So finding the composite function is easy. So we're going to go that route. And now we can differentiate this using the extended power rule. L prime or dl dt is this number times the same thing times the exponent 2.543, then times the parentheses, the same thing to the power of subtract 1. So same thing to the power of 1.543. By the chain rule now, the derivative of the inside is just 0.18. And if I multiply those three numbers, I get this one. And take a look. These two are identical. If I had changed the W to the function W of T, I would have got exactly the same thing. And we are done. They didn't ask for the length, but just in case, if they ask for the length, L of 30, so plug in 30, you can calculate it. And the way you do that, you can see the formula here, W, replace it with 5.525, or this one, replace the T in this one with 30, it gives you the length. So there are two ways to calculate them now that we have the composite function. Either way is fine. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. In general, there are a few things that will help us graph a function. Peaks and valleys. Local mean, local max, local mean. And if you draw a tangent line, it's horizontal, f prime is 0. Decreasing, increasing, decreasing, increasing. The function is increasing, f prime is positive, decreasing is negative. So we should have this information. Relative max or mean, f prime is 0. When f prime is positive, f is increasing. When it's negative, f is decreasing. Therefore, first and foremost, those easy 3 points correspond to x-intercepts of f prime. So at A, the y-coordinate is 0 because the slope is 0 for f prime. Same thing for B and C. So those are the 3 x-intercepts. Over here, the function is decreasing, which makes f prime negative. That means below the x-axis. Over here, the function is increasing, which makes f prime positive, so above the x-axis. But as it goes up, at B, it's back to 0, so it has to come back down at some point. This portion is obviously decreasing, which makes f prime negative, so it goes below the x-axis. But at C, or corresponding to that point, C prime must come back up to 0. And this is obviously increasing above the x-axis. And as far as this point is concerned, you can try your best to come up with a couple of points on a tangent line, calculate the slope roughly 3/2. This corresponds to the 0.5, 3/2 or 1.5 on the graph of the derivative of the function. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. Notice you have a line segment. This would be a line, goes indefinitely, but it's a line segment, 1, 2, 3, 4. So what I want to add first and foremost, a function fails to be differentiable if it has a sharp corner, discontinuity such as a jump, and a vertical tangent line. So we have a sharp corner, 3 of them here. But understand that we are dealing with line segments. Let's throw in some numbers and use those numbers to calculate the slope rise over run, delta y over delta x. So for example, for this line segment, 0 minus 1 over minus 1 minus minus 3 gives us m equals negative 1/2. We have to do the same thing for all of them, which means this one has the same slope but positive. This one we can calculate and we get m equals 1, and this one we get m equals negative 1. So for the sake of argument, this one, if it was a line and it continued indefinitely, it would correspond to y equals negative 1/2. Okay, so in other words, let's say this was a line, another line segment, y equals minus 1/2 would be the answer, and we would be done. Of course, there are 4 pieces. So one thing I want everybody to notice, sharp corner, sharp corner, sharp corner. Therefore, for the first part, it covers from here to here. This endpoint is a sharp corner, and it stops here, and it continues this way. But what about the rest of them? Well, m equals 1, m equals negative 1, m equals 1/2. Those would be the y-intercept. Those would be the equation of a horizontal tangent lines in horizontal lines. My apologies. Having said that, y equals 1 goes this way, but it is restricted between the two numbers here, so it's going to be from here to here, and the endpoints, both of them have holes. This third one from here to here, and the last one from here on. And notice all of them, the endpoints, there is a hole here, there's a hole here, 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 and because a function fails to be differentiable if it has a sharp corner. So that would be the final answer.